Hello everyone, the next topic in data structure is stack. Stack is a linear data structure. As we have seen in my previous video, the types of data structure, so stack is a linear data structure and the elements in stack are stored in a sequential manner. Okay. Now the definition of stack. So a stack is an ordered collection of homogeneous data elements. Now what is the meaning of homogeneous? If we have created a stack for integer, then only integer elements will be stored into the stack. And if we have created a stack for character, then only character elements can be stored into the stack. Okay. Where the insertion and deletion takes place at one end known as top. There is one single end known as top end, and this single end is responsible for inserting an element into the stack and deleting an element from the stack. See, let us consider a stack like this, and the top is pointing here, and from this end the elements are inserted into the stack, and from this end only the elements are deleted from the stack. So this single end is responsible for insertion and deletion. Okay. Also, the stack is called as last in and first out, LIFO. Last in, first out. What is the meaning of LIFO? The element which is inserted last into the stack must be deleted first. Whichever element which will be inserted last into the stack will be deleted first. Okay, let me explain you this with the help of an example. So, consider number of plates in cafeteria. So, let me draw. This is a tray. Okay. Now we have to insert plate into this tray. So we will insert like this. Plate 1, another plate, 2 and plate 3. So suppose we have inserted 3 plates on this tray. Now the last plate which we inserted on this tray is plate 3. So write here plate 3 last. Okay. So plate 3 is inserted last, isn't it? Now we have to remove plate 1. So for removing plate 1, we have to first remove plate 3 and then plate 2. Unless and until we remove plate 3 and plate 2, we cannot remove plate 1. Okay. So we know that plate 3 was the last plate which we inserted, right? Plate 3 was the last plate while inserting. Now, while removing, plate 3 is the first plate. So we can write here as plate 3 first removed. Isn't it? So plate 3 is first removed and then plate 2 and finally then plate 1. So this is the meaning of last in, first out, and stack follows this principle. Okay. Now let us understand the basic operations of stack, and they are insertion, deletion and display. So what is the meaning of insertion? Insertion is inserting or adding an element into the stack, and the terminology used for insertion in stack is push. So push is inserting or adding an element into the stack using top. Okay. Any data element or object is inserted into the stack using top. Object inserted into stack using top. Okay. Now, what is the meaning of deletion? So, deleting or removing an element from the stack, and the terminology used for deletion in stack is pop. So, pop is deleting or removing an element from the stack using top. push, pop. All these operations are performed using the same and top. Okay. And the next operation is the display operation. So whichever elements which are present into the stack, they are displayed using the display operation. Okay. And then there are two conditions, is empty and is full conditions. What is the meaning of is empty? It reports whether the stack is empty. What this condition will say? Whether the stack is empty. And this condition is very important when we want to insert an element into the stack. That is, when we want to push an element into the stack, we need to check whether the stack is empty. And if the stack is empty, that is, if this condition is true. If this condition is true, what it says? That the stack is empty, there is place into the stack to accommodate new element. So at that time we can perform the push operation if this condition is true. And if this condition is false, what it says? That the stack is not empty. It means the stack is full and there is no place for further elements to be inserted. So for push operation we have to check is empty condition. Okay. And it has to be true. The next condition is the is full condition. What this condition says? Whether the stack exceeds its limit. Means whether the stack is full. And if the stack is already full, we cannot perform push into the stack. Means if this condition is true. If this condition is true, it means that the stack is full. And if stack is full, we cannot insert new elements into the stack, which means we cannot perform push into the stack. Cannot perform. Okay. We cannot perform push into the stack if this condition is true, right? Because if the stack is already full, how can we insert an element into the stack? Isn't it? See, consider this stack. There are elements into this. Now the stack is already full and we want to insert 50 into this stack, right? So we cannot insert 50 into the stack because the stack is full, which means we cannot insert 50 element into the stack, which means we cannot perform push into the stack because the stack is full. Okay. Let us understand these operations with the help of an example. So consider an example as elements are inserted in the order as A, B, C, D, E. So we have to insert these 5 elements to take stack of 5 elements. Okay. First. Initially top is at -1. This is the initial condition and it indicates underflow, stack underflow, which means stack is empty. And when this condition is true, then only we can insert elements into the stack. Okay, this condition is true. So now we can insert element into the stack. The top will be incremented first. Okay. Top will be incremented. It will point here. Okay. And element A will be pushed. Now again top will be incremented. Here top equals to 0. And here top equals to 1. And push B. B. Now again top will be implemented. Top will be at 2, element C. Now top will be at 3. Again, top will be incremented. Okay. So now all the elements are inserted into the stack, and now stack is full. And now if we try to insert more elements into the stack, so it will indicate stack overflow condition, which also indicate that stack is full and no further elements can be inserted into the stack. Now we will delete element from the stack. For deleting, the element which will be at the top of the stack will be deleted first. So now pop E. So here we have to not mention any argument, okay? Because the element, it is understood, the element which is at the top will be removed. So there no need of passing argument, okay? So we will not pass any argument for pop operation. So E is pop, and now top will be decremented and it will point to 3. Okay. In this way, the elements will be removed or pop, and top will be decremented. Okay. Now again top equals to -1, which is underflow, and which indicates stack is empty. So in this way elements are pushed into the stack and elements are popped from the stack. Now the most important part is implementation of stack using array. The first operation is the push operation, and in this we need to give the size of stack before performing insertion. Okay. So now size equal to 10, which means maximum 10 elements can be inserted, and initial condition as top equal to -1. So this is the initial condition. Let us consider a stack and top equals to -1 is the initial condition. Okay. Now perform main push. So first we need to read the element which we have to push into the stack. So declare a stack also, stack and array. Okay. So read the element scanf %d element. So let us consider this element is an integer element. So %d is a format specifier. Now the condition if. So for push operation we need to check the stack overflow condition. If top equals to size 9, which means if top is equal to size -1, if this condition is true, which means stack is full. So just print here stack is full, overflow condition. And if stack is full, we cannot perform push operation. But if this condition is false, then else top plus plus, the top will be incremented and stack of top equals to element, the element which we want to insert. This is a simple push operation. Now let us understand this in detail. Now the first iteration. So let us consider we want to insert 10 into this stack, element 10 into this stack. For the condition is top equal to size minus 1. So top is minus 1 and size is 10. So 10 minus 1 is 9. So if minus 1 equals to 9, no, condition is false. So this condition is false. So it will go into the else part. Top will be incremented. Presently top is at minus 1. Now top will be at 0 here, and stack of top equals to element, means stack of 0 equal to element. So at 0th position element will be inserted, element 10. So 10 will be inserted here. Now suppose we want to insert 20 into this stack. So again, now top is at 0. So 0 equals to 9. No, condition is false. So it will go into else part. Top plus plus. Again top will be incremented. Now top will be at 1 at this position. And stack of top equal to element. Stack of 1 equal to element. So at this position 20 will be inserted. Now 30. Now stack is at 1. So 1 equals to 9. No, condition is false. So again it will come into the else part. Top plus plus. Now top will be at 2. And stack of top equal to element. So stack of 2 equal to element. Now at this position 30 will be inserted. So in this way push operation will take place. Now the second operation is the pop operation. So for performing pop operation we have to check stack underflow condition, and if that condition is true, pop operation cannot be performed. Okay. So if top equals to minus 1, this is stack underflow condition, and so if this is true we have to print stack is empty, or we can also print as underflow. So if this condition is true, then stack is empty, pop operation cannot be performed. But if this condition is false, then else element equal to stack of top. The element which is at the top position of the stack, we have to remove that. So element equal to stack of top, and then top minus minus, decrement the top. So this is a simple pop operation. Okay. Now let us understand this with the help of this example. So the first element which we want to pop is 30, right? So first we will check if top equals to minus 1. Initially top is at 2, right? So 2 equals to minus 1. No, condition is false. So this condition is false. So it will go into the else part. So element equal to stack of top. Element equal to stack of top. Now the top is at 2. So stack of 2. The element at the stack of 2 is 30, right? Which element is here? 30. So 30 will be popped and top will be decremented. So now top will be at 1, right? Now here we will check whether 1 equals to minus 1. No, condition is false. So we will not enter in this part. Else part, element stack of top. Which element is at stack of top? The top is 1. So stack of 1, and it's stack of 1, 20. So 20 will be popped. And top minus minus. So top will be at 0. Now 0 is equal equal to -1? No, condition is false. So again else part, element which is at the 0th position of the stack, that is 10, will be popped. And now top minus minus. So now top will be at -1. Now once again we will check. So now top is at -1. So -1 equals to -1. Yes, condition is true. So what it will print? Stack is empty. And if stack is empty, no pop operation will be performed. Okay. So this was a simple pop operation. The third operation is the display operation. Consider a stack like this. Has 4 elements and top is at 3. Okay. So this is a stack which has 4 elements, and now we have to display the elements of this stack using the display operation. So the condition is if top is not equal to -1, because if top is equal to -1, which means stack is empty, and if stack is empty, there is nothing to display. So top should be not equal to -1. Okay. So if this condition is true, then for I equals to top, I is greater than equals to 0, I -1. And this will print the elements of the stack. %d stack of 5. Okay. But in case if this condition is not true, in that case else printf stack is empty. Okay. Now let us understand it in detail. So now top is at 3. Okay. So 3 is not equal to -1. Condition is true. So for I equals to top, I equals to 3. Now value of I is 3. And 3 is greater than equals to 0. Right? Condition true. So printf %d stack of I. Stack of I means stack of 3. Now the element which is at this position, stack of 3, is 40. Okay. So 40 will be displayed. Now again in second iteration, what will happen? I minus minus. So now I is 2. I equals to 2. Right? And 2 is greater than equal to 0. Right? Now again printf stack of 2. The element which is at the second position is 30. Now 30 will be displayed. Now again I will be decremented. So I will be equal to 1. I decremented, I equal to 1. I is means 1 is greater than equals to 0. Yes. So again printf stack of 1. Stack of 1 is 20. So 20 will be printed. Again I will be decremented. I minus minus. So I equal to 0. So 0 is greater than equals to 0. Yes. 0 is equal to 0. The stack of 0 at 0th position, 10 is there. So 10 will be displayed. Yes. And after that again I will be decremented and I will be equal to -1. I will be equal to -1. So -1 is greater than equal to 0. No, condition is false. And when condition is false, else printf stack is empty. So this was a simple display operation. Hope you understood my today's lecture. And if so, then give this video a big thumbs up, subscribe to my channel, and Also share it with your friends. In my next video, we will see the another linear data structure, that is cube.